Let me know if you can see my screen.
Yeah, it's
Cool.
visible.
Okay. I'll just start with a little warm up. Cool. So like I just want to know what is the audience like? How many of you are in your first year, or how many of you are in your second year, or subsequent? So can just first year people like raise their hands? Okay, 4 to 5. Okay, and second year people. Okay, and how many of you are in computer science branch? Okay, okay, I get the idea. Uh, so is everyone new to this topic like machine learning, AI, or do you know a little bit, bits and bits about it? So are you familiar with any of the concept or used any application before somewhere, or is it completely new? Like, uh, you can just let me know by raising your hands if it's completely new to you. Okay, almost most of you. But I'm sure like everyone is using this application every day, either with their smartphones, voice recognition, etc., etc. But so this session is like basically like a pavestone of what understanding should be if you want to understand about machine learning or AI, or want to learn it, or even want to make a career into it. So before diving into any of it, like how to start, what to do, what are the jobs, we will actually be starting from very basics. So okay, okay, I think I need to present it. Yeah. Uh, so we will be talking about patterns. First thing, what patterns are. Like, if someone can let me know what is a pattern, if anyone just want to speak up, and I think you people have the access to the mic. So can anyone just let me know what is a pattern? No one knows what a pattern is.
Some sequence which follows some set of functions or relationship can be called a pattern.
Okay, not entirely correct, but anyone else? Okay. So she just mentioned like a set of function or something, and function is defined by some constraints, but we should not go too much mathematical because a lot of patterns actually cannot be defined into a function. So later on, I will actually give you examples. So if you just want to understand into very layman terms, like what pattern is, it's like connecting different dots. If you're finding some kind of similarity, or is it some kind of abstraction and you are making it to a form of precision, or maybe it's just connecting laws of nature to programming, because now we are talking about AI and ML, or like uncovering the patterns that we actually see around us, the day-to-day things that we see around us. uh, Everything actually follows certain kind of pattern, be it your sleep cycle, be it your weather cycle, be it your own thought process, like how you think, that actually also follows a pattern, right? uh, the patterns that you found in nature. So if you can just see at the example of a shell, or so if you can just look at this tree, which is basically a sphere, and the branches and the sub branches are also basically forming a spherical pattern. uh, okay, the waves of a river, the dunes on a desert, Even the constellation stars, there are some kind of patterns, and most of them look random to us, but most of them actually are similar or following a certain kind of same representation. Am I right? So, can anyone just guess this graph, like what this graph basically means, if you can look at it? Yeah,
It is basically representation of golden ratio which comes from Fibonacci series.
yeah, right, correct. It's a Fibonacci series. So it's one of the mathematical series, and in nature, nature actually follows a lot of Fibonacci series and sequence representation. For example, this particular image from a cell, it's basically a combination of different Fibonacci sequences, right? Uh, this shell representation, it's basically a exponential logarithmic sequence. Um, to give you example of how in nature we are finding a lot of underlying mathematical patterns. I won't say mathematical patterns, but we use mathematics to basically define them, and a lot of patterns cannot be defined into mathematical modeling yet, or into any kind of empirical model yet. So if you see the growth of if you see the repeating patterns of the season or growth patterns of certain plant, it basically follows some kind of algebraic sequences. And calculus, if you think of where we are using calculus, it's a way to optimize resources by adjusting growth rates or the way animals navigate their environment. So if you look back in the way evolutionary science basically developed, animals use their own common understanding to navigate a lot of things around their environments and optimize resources, like okay, where they might be getting this much food, how much they should save for the season. So it's basically their own calculus, the rate at which they should speed up or slow down, etc. Coming to another example, which is of game theory. So animals also use some kind of strategic behaviors during mating rituals or territorial disputes, or even humans do that. So it's basically an example of game theory, and before even game theory existed, we were somehow kind of doing that. Cryptography, I am not sure. I think second year people might have heard this term a lot about cryptography, but this basically came from the technique that like animal often use, which is camouflage or mimicry, mimic to conceal themselves from predators or prey. Then another example is differential equations. So differential equations again is a subject of your own mathematics, and I think it does come in second year applied mathematics course. Uh, so growth of populations, proliferation of bacteria, and spread of disease in a community, it all example of differential equation. Then the subtopic, which is partial differential equation, natural phenomena like propagation of waves in water, spread of heat through a material, all comes into partial differential equation. Ordinary differential equation, how the movement of celestial bodies like planets and moons, like how they basically move, they also come under the pattern of a ordinary differential equation. Again a new term, graph theory. Graph theory, again a mathematical term, but it also basically takes inspiration from how like species animal among species connect to their social interaction, or the example of food webs. Linear algebra, as we just talked about, balance of force within an ecosystem, or for example, the tension in a spider web. The concept of probability, I think it's very common, like exhibiting the likelihood of finding food, chance of encountering predators, and statistics again, um, like the growing ongoing population of human in a certain or particular geographic location, weather patterns, or even migration of animals or birds. So, like just learning about how nature plays an important role into making our understanding more depth of observations. Like it's all about observations and identifying certain kind of patterns. And I do think patterns are really important. That's one of the most important skill, whether you find underlying patterns as a form of mathematical model or even without it. It's actually one of the important skill. Uh, Again, to give an example, patterns in human psychology. So, okay, I'm gonna tell a very interesting story. How many of you have watched Harry Potter? Okay, how many of you are interested in Marvel or Disney movies? Okay, any kind of mythology like Greek mythology or Indian mythology, or animes, for example. Okay, cool. So if you see how all these writers, like who write all these stories, develop their character, so there might or even like fairy tale stories like Beauty and the Beast, Sleeping Beauty, Cinderella. So if you will look at a very detailed analysis of each of the character, uh, like there are some certain kind of similarities or patterns followed, and these human personalities were basically defined under the terms called archetype. So Carl Jung was the founder of analytical psychology and also gave symbolism, which can basically interpret a lot of different type of characters into 8 subtypes, which are called archetypes. So maybe that's an interesting homework you can do, like to find out the psychology of making a character. So especially for example in animes, there is a psychology of a shadow archetype. A lot of shadow archetype is being followed where the main character is followed by some past dark sides or traumas, and then it goes into a lot of work on themselves and like do something really good in life. And why I gave you examples of like asked you to know like about Harry Potter or anime or all these movies, uh, I'm not sure, but you might have explored this idea of a flying object. In most of the pictures or stories, if there is a kind of a flying object, it's basically and the main character or the protagonist is always attracted by that kind of a flying character. For example, in Greek mythology, it's Lord Hermes. So Hermes is basically a messenger god who comes to the protagonist whenever the protagonist is in trouble, and like give some kind of a wisdom so that protagonists know what to do next in life. And so there was this ball kind of flying character, flying object in the Harry Potter series itself, to which Harry was attracted. So basically, that flying object is trying to tell a kind of a flickering intuition, right? I'm not sure how much you get it, but the idea behind this is some kind of objects, some kind of patterns exist to define a certain kind of a idea. So this idea of flickering intuition basically comes under analytical psychology or even human patterns and behaviors. Um, and it basically like have its shape in interpreting dreams, myths, cultural symbols, revealing deeper insights into the human psyche. uh, Another example is Bayesian inference, which is a statistical method used to update beliefs and making decisions in the process of uncertainty. So so like how human do decision making, like their own perception, judgment, or reasoning, they are basically based on some kind of belief of if or not, if this exists and this does not exist. It's basically idea of Bayesian inference, which follows mathematical probability rule of theorem, like the happening of an event when another event exists. So these kind of models took place after understanding the human psychology itself. Another example is computational linguistics. So computational linguistics is basically employing mathematical and computational methods for studying language, their structure, their usage, semantics, how they basically developed, and using like AI techniques, which I will be explaining you later, like what natural language processing is. So it's basically implementation of a AI model to understand language. So, okay, coming back to the question again, like why these patterns are actually formed. Like you might ask a question, like why these patterns even exist in nature, or how can we even say like is everything defined by a pattern, or is it just random? It can be something just random, right? So there are a lot of theories given by people, biologists, evolutionary psychologists, like that they might be depending on natural selection of animals or even the way chemical diffuses when any kind of reaction happens. For example, like after an earthquake or after a famine, the earth takes a particular kind of a structure. So there have been many theories developed, but before answering this question, like does patterns exist everywhere, we have to know what exactly is a pattern. Coming back to the question, when I asked if any one of you knows what a pattern is. So, okay, to answer this question, like I think we think of patterns as something that repeats again and again. So she just gave an example that it's a function. But like if anyone just asks you a question, what is a pattern? You might think, okay, it repeats again and again throughout the space in some sort of a identical way, like maybe a wallpaper pattern or a pattern on a t-shirt. It's maybe repeating or a check pattern. um, but many patterns that we see in nature are are not like that. So we sense there is something regular or at least not random about them. So regular patterns does not mean they're identical. They will be somewhere different. For example, um, spots on a leopard or stripes on a zebra. Like if you will closely look at the stripes of the zebra, you might see are like this is following some pattern and they do look identical, but actually they are not identical. They are just regular. Um, and even like clouds in the sky, you might see okay, a lot of clouds are identical, but honestly no cloud is like any other cloud. There will be some kind of small difference. How many of you play video games? Like, okay, a lot of people. So if you play video games or if you're interested in like game development, you might see like just a small example. Somewhere Mario khela hoga. Everyone have played Mario, right? So there are those trees. You see those trees in the video game, and they might look all identical to you, right? कि okay, सारे पेड़ एक जैसे हैं, but they are not same. Every tree is different from them, but they are defined between two constraints and they are given a random noise. So this random noise actually exists in nature also. So I think we can make a case saying that anything that is not purely random has some kind of pattern in it and some kind of regularity. So actually in nature there is something which is pulling everything which is existing from pure randomness. Pure randomness actually does not exist, or at the other end, like neither pure uniformity exists. Nothing is purely uniform or nothing is purely random. So just to give you example, like what that noise was that we were talking about in the video games, it's called Perlin noise. So Perlin noise exists in nature where a uniform kind of noise is spreads their values, but across a fixed range. Like for example, maybe 0 to zero point 0.8. So there will be two extremes, and a uniform noise will be spreading. So Perlin noise, like the cloud example, is also example of Perlin noise. So between two extents, there is some noise, and all the kinds of these objects are formed between these particular extremes. Another term you might have heard, I'm not sure. Have any of you heard of this term called Gaussian noise? So, okay, Gaussian noise also follows a normal distribution. It spreads equally, but around the mean. So, it does not have two extremes. It actually spreads equally around the mean value of both of the extremes. And this is a term, so Gaussian noise is also found in a lot of examples in nature. And just to give you a heads up, uh, In a lot of machine learning models, we use Gaussian noise a lot to introduce Gaussian noise because we want to make data look more like of a natural data. Any question till now? Like, are you following up with the flow? If you are, you can just like do thumbs up. Okay, cool. So now we have talked about patterns. Like we have understood, okay, where are we following? We understood like patterns exist in nature, what to do with patterns. There are examples where mathematics have a lot of underlying examples. Mathematics have basically defined a lot of nature laws into its own subjects. But what about programming? Like what programming is about? Computer programming, and a lot of people might have already started with learning it. A lot of you might have already be doing during the school times. So one question: what is at the core of every program? And I want you to answer it without looking at the slide. Like what do you think, what is at the core of programming? And you can come up with any of your understanding or any of your interesting answer, but I want to like hear at least who have been doing computer programming for some time. Anyone? I mean, at least who are doing computer programming, what do you understand by it? Like what you are doing, what do you feel about it when you write a code or like anything?
I mean, if we cut down to the basic side, it's simply human talking to the machine, like basic thing.
Human, sorry, what?
If you cut down to the basic, it's just the human talking to the machine. In the
Human
system.
talking to machine. Okay. Okay, human is talking to machine, but when the human is talking or basically providing any kind of instruction, what is lying at the core of it? Like what's basically human is trying to do? Like
Ones and
yeah.
zeros.
Sorry?
The binary ones and zeros. He said the
Oh,
binary.
I didn't get. Can you repeat? I'm sorry.
The binary digits 0, 1.
Okay. That things computer is doing. I'm asking what you are doing. What is at the core of your own program?
Like, are we going through that thing that we understand the problem and we are trying to solve it through initialization, declaration, and then like writing the program for to solve the problem actually.
Basically, you are trying to solve a problem or you are trying to find an answer to something using computer.
Giving instructions to computer.
Okay. Yeah, kind of same answer. So basically, you are giving instructions to computer, and to give those instructions, you are writing a program, which is basically a set of instruction. Uh, but how you are doing it? Like that's what I was asking. So you cannot say, okay, I learned some kind of syntax and I know this and I want this particular kind of output. You have to think from a little broader perspective of how, like what exactly at the core of any kind of program that you write, whatever kind of programming you are doing right now, or whatever kind of programming people are doing, or any kind of job people are doing, basically even from the earlier times to now where there are a lot of fast and better compiled languages, right? So at the core of it there lies abstractions that we were talking about, the patterns, like how we saw patterns as abstractions, and mathematicians and the people who were basically observing defined it into a kind of a mathematical model. So same with computer programming. So basically we are trying to do a process of abstraction, and one thing is like, is this process of abstraction is specific to programming only or not? Uh, so I'll ask this question later, but what about computers? Like, computers are the tools that deal with these abstractions, and there are basically three parts of every computer. So लोगों ने कंप्यूटर बनाया एंड people will say कि हाँ mathematically complex or large sums को solve करने के लिए which were taking a lot of time, these supercomputers made, and then edge technology and the small chips, and then we are doing a lot of computational stuff. But how exactly the idea of these like even computers formed? To look at the abstraction, so we have three rings in this universe, like an internal clock, which is a computer's way to abstract time. कि आप time को abstract कर लो. And then we talk about memory, like memory a lot in data structures and programming, which is a computer's way to abstract the space. Uh, just think of it as a space, like in a universe. Like to abstract that space, we say in terms of memory in computer. And then a processing unit, which is a computer's way to perform logical operations like we do in our brain, right? So we abstracted all these things which exist in nature into computer, right? And I will give you an example of how like adopting or doing this process of abstraction lies under the core of programming. So okay, there is a subject called design patterns. Like if you will learn about like design patterns in programming, or if any of you have experience with object oriented programming, there is a pattern called strategy pattern. So this strategy pattern is a behavioral science pattern that allows you to define a family of algorithms, encapsulate them into separate classes, and make them changeable at a runtime. The strategy can vary the behavior of an object without changing its structure or interference. This pattern is similar to how nature adapts to different environment, challenges, or opportunities by selecting the best strategy for survival. So basically, strategy pattern is selecting the best strategy for survival, and the same kind of design pattern we do follow in programming also. So like even the basic idea of object oriented programming of making classes and then objects, um, and even when you learn the object oriented programming lessons, they tell you how, for example, there is a family and then there are kids which are basically subclasses, or sorry, objects in a class, and they follow the same thing which for which a class is defined. But all these ideas are basically, so the main point is these ideas are basically taken from nature, and with programming we do a process of abstraction. So that was the main idea, like writing any program in a particular method. Like you might ask if I okay, if any one of you ever have started with Java, like, and Java is object oriented language, it follows some certain kind of rules of how do you write that language in a particular design pattern. So basically, all these patterns are adopted from nature to perform or have certain kind of outputs. So then talking about like traditional computer programming, which basically involves, and most of you are doing that, writing explicit instructions, algorithms for a computer to follow a particular specific task. So, for example, doing a simple addition, or doing a simple multiplication, or even finding a compound interest. So that might be a task for you to do, which you can give to computer by providing some instructions, writing a program, a C++ program, or a Python program. But the behavior of these programs are very deterministic, which means it produces the same output. Like whenever you give the same input, it will produce the same output. And these kind of programs are limited by programmers understanding and ability to anticipate all possible case scenarios. So आप लोग को बहुत सारे these problem questions मिलते होंगे that you have to pass all these cases, right? All these test cases, different kind of test cases, right? I'm not sure how many of you are doing uh, what we call competitive coding, yeah. So for a particular problem statement, there are a lot of kind of test cases, and the programmer's ability to anticipate all those possible scenarios and write a robust code. Ki, okay, this will work in all possible scenarios. It's limited by your own ability. So these all these things come under traditional programming language, but what about the case when you have to deal with uncertainty? or complex or non-linear problems. For example, uh, finance risk management, power grid optimization, route planning. Um, a very basic example of route planning. So Shivratri is coming, right? And a lot of people do this Kawad Yatra. And there is a problem of stampede, especially in India where population is so much. And at any kind of major festival procession, there is always a problem of stampede happening. So in that case, you have to do a certain kind of route planning. Okay, these are the paths people will come from here, or even in the election campaign. So there will always be a planning. What are the exit points? What if like these number of people come? Where will they enter? Where will they exit from? And especially if it's for longer routes, right? So these kind of route planning, can you write a program for it? Like, can anyone define some kind of logic, okay, and do write a program for it? It's pretty impossible, right? Because there is uncertainty. You do not know the problems, constraints itself, and then basically it becomes an example of a non-linear problem. So what do we use in that case? So we have some different certain branches and tools to solve uncertain problems. One of them is machine learning, which we will be talking about. Then deep learning. Another subject is soft computing, expert systems, rule-based systems, evolutionary algorithms, swarm intelligence. So I never studied computer science. Like I was not from a computer science branch in my undergrad, but uh, are you taking your soft computing course? Is anyone taking a soft computing course? Okay, I don't think so. So, okay, I'll just dive deep into it, like how all these different branches do solve uncertainty or like complex problems. So, soft computing is a part, like, is a domain where it provides approximate solution to complex problem, where exact solutions may be difficult or impossible to find. For example, fuzzy logic systems, neural networks, genetic algorithms, and evolutionary algorithms. So, ABS system, it's an anti-braking system where roads are uneven, and uh, so in the cars where there are automatic brakes in kind of any emergency situation, you want to improve the overall safety and stability also, but there are a lot of variables in that, which includes like changing road conditions and the input of the driver. So fuzzy logic system is basically it's a set of verbal instructions you give. It gives you sort of fuzzy answers which you convert into some certain answers. So this is one example. Another example of soft computing, which is using genetic algorithms. So genetic algorithms are basically used to optimize situations like delivery routes. Delivery routes, for example, considering factors like traffic condition, delivery deadlines, capacities of vehicle, like just like Amazon delivery, right? So it has to provide near optimal solution in situations, or even your 10-minute Dunzo or Zepto. They all use genetic algorithms to run their entire system. And another sub branch, which is machine learning. Machine learning is basically a subset of AI. Even soft computing is a subset of AI that focuses on developing algorithms and statistical methods that allow computers to perform tasks without being explicitly programmed. So they mainly rely on just understanding the data around. They do not have to be programmed. They basically learn to identify patterns in the data. Deep learning, which is again a specialized subset of machine learning, and it uses something called artificial neural networks. So artificial neural network is a part of soft computing also, but deep learning is itself a very specialized branch because it uses another subdomains like image processing, computer vision to accomplish different kind of tasks. um, Another domain called swarm intelligence. So some intelligence is a collective behavior which is observed in a decentralized self-organized systems. So some intelligence is an example where we can solve that stampede problem that I just discussed about. Um, an example of swarm intelligence algorithm is ant colony optimization, and they do teach like in computer science courses, like all these kind of algorithms. Very famous rule based systems, like before learning machine learning, people mostly do learn about rule based system, and this was the way people used to solve a lot of uncertain tasks before machine learning came into existence. So rule-based systems, they use a declarative approach to problem solving where knowledge is represented explicitly in the form of rules. So these are the certain kind of rules. For example, any kind of task that AI performs right now. For example, predicting the stock price in the future. So if you had to use a rule-based system for that, you will be just having a certain number of rules. So this is a trend that we have observed. Stock price never goes less to this, or it cannot go higher than this, and etc. and etc. You will be providing certain kind of rules already to a system, and that these rules encode in that particular specific expertise, and then it allows system to make decisions or draw conclusions on the basis of data and its own observations. So um did you understand the difference between each of it, and why do we have a need of a specifically machine learning or deep learning, and like which areas we have to use other kind of domains to solve complex problems? So these pointers were basically mentioned to make a understanding in your mind that not every problem is a AI or ML problem. Not every problem can be solved by those traditional programming methods. Um, and especially for a lot of complex problems that do exist in nature, there are like these particular sets of branches that people are using in computer science to come to conclusions or tackle these tasks. But we will be talking specifically about using machine learning or deep learning because it has been used in a combination with soft computing and even the rule based systems um, to make the performance and output better and improve the accuracy. So, how to start with machine learning? Machine learning requires your understanding of having a basic programming knowledge. So, how many of you have started like with learning at least one programming language, like at least one? Okay, so I see like one or two hands down, and I really urge you to start as soon as with it, because it is not about learning the subjects, it's also making your own understanding broader. So it's just your sport, like you have to learn it uh, in any kind of domain or field you go. So that's a good thing. Starting with one programming language, or and if you're like trying to go or learn about machine learning, it has to be more of object oriented programming. Then another set of requirements is studying about mathematics, and specifically four topics, which is statistics, probability, linear algebra, and calculus. And another requirement is data tackling. You should know what is a data structure, how data is stored, databases, and some a little bit of web scraping. Because if you are starting with machine learning, you need to learn about data and how to collect data. And when you are doing it from the internet, you basically collect it with the process of web scraping. So I think these are the like it's my own understanding and my own experience, which I think like three basic requirements you must have. And I've listed down these courses and linked like machine learning Stanford course, practical deep learning, like good to start with, very basic. And like everyone I think should go to these three courses specifically. This one is pretty specific for NLP. You can like dive deep later into it. but starting with ML and TL, these are good. With mathematic concepts, I won't like suggest you to like actually do a course, but like even reading with the blogs or watching a YouTube playlist, especially for ML for these four topics, will be like really good enough. And it's a GitHub link for awesome ML courses. It have a lot of beginner friendly and even advanced courses linked into it. So approaches like, now, okay, you know about machine learning, you know about, okay, it's a place where we have to uh, like find solutions to complex problem uncertainties or predicting something. So, and we now have to learn it, but like what's the way, like what's the way to start with it? So there are two approaches like to learn anything, which is a bottom up approach. You start everything from zero scratch, uh, gain a lot of understanding about it, and then climb the stair. And then there's a top down approach, but what's the problem with bottom up approach is like very anxious time tackling. So you might be collecting a lot of courses, taking a month or two to complete every courses, practice it, then again revise it, and there's just not one, there are like multiple things. So it will make you anxious, a lot of overwhelm, and it will actually take a lot of time, but anyway, it's eventually going to be fruitful. But then there's a top down approach, which is dangerous because you will be having half knowledge, half baked thoughts, and half baked understanding. And it will be, sorry, it has to be iterative. Like you have to do iterations multiple times to like make your understanding more better. But it's basically fun. Like that's how I started with machine learning. So what's in the top down approach? Don't start with precursor maths. Like you don't have to go to all these kind of mathematical courses, learn everything about statistics. Honestly, neither I have understanding of each and every kind of depth topic in these four subdomains of mathematics that I just showed. um, you do not have to code every algorithm from scratch. There are multiple algorithms under machine learning, and which requires like your proper understanding. But that abstract understanding is good enough, even if you can't code it from scratch right now. So yeah, you have to refine later, but you do have to refine it later. And you have to connect your dots from this abstract knowledge that you gain if you basically learn about an example called random forest algorithm machine learning. Um, it basically follows nodes and branches, like these kind of topics. So uh, gaining an abstract knowledge is like really good enough, you can refine it later. So you have to start by learning how to work through very simple predictive modeling approach using a fixed framework with free and easy to use open source tools. So there are a lot of open source tools and frameworks which can help you like getting started. For example, scikit-learn is a Python package which basically gives you all these algorithms already coded. And you have to practice on many small projects and slowly increase their complexity. So start with one small project, learn about like how it is happening, or maybe just take a tutorial on a project, and then start increasing their complexity. Go through basic blogs, or at least take one basic ML course, and you will be good to go, you will be good to understand. But this is a good enough approach. You will soon be at least having one project which will be making you confident enough to go with the pace and maintain your flow. So these are some tools to start with. Um, anyway, I think I will be sharing this presentation to all of you, so it's okay even if you don't take pictures. Um, Kaggle, Python notebooks, Vika Workbench. So if you're not familiar with any kind of ID or not even programming from before, just start with basic Python notebooks. It's just a rough notebooks where you can use Python syntax to do any kind of a machine learning code. Kaggle is also basically like it's a Jupyter notebook, but Kaggle have a lot of databases. People can post their tutorials, blogs. So it's a like it's a must platform you should know about. You should know how to use, and it's a good community out there at Kaggle if you're starting or want to start with machine learning or deep learning. Yeah. Explore a lot of open source data sets that can easily be found on Kaggle. Practice machine learning workflow. So machine learning workflow actually involves multiple steps, which is data gathering, doing feature engineering on data, because whatever data we get is a lot of random. And again, as we do in traditional programming, we provide certain kind of inputs to computers. So we have to uh, gather certain kind of features from the data, which we can provide to our ML model, which is basically like you can just create an anatomy like a computer program. So to provide this data to a ML model, we have to choose certain kind of features or modify them in certain way, which is called feature engineering. And after we do all that, even we get an output from our ML model, we should be learning how to make ML APIs so that it can be used in different programs and different like if you have to make an application. So this is basically you have to like learn this entire workflow after starting with like a basic understanding, making a small project. And a knowledge of basic command line is like really important. Setting up environment, handling your dependency issues, these are, and whatever I'm just telling, these are honestly just basics. Like you really have to get your hands on it, and it's nothing overwhelming. I think like even if you spend like 5 days on these first 3 points, you will be like really good to go. 2 days for like learning basic command line and setting it to, or even just take a week, that would be fine, but you will be getting like really good with this also. These are some tools that like you will often be using: Jupyter, NumPy, scikit-learn, Matplotlib, TensorFlow, Keras. um, it's like TensorFlow, Keras are frameworks. It's a visualization tool. So these are kind of tools you will be using while you will be starting with your ML practice. For deep learning specifically, Keras, PyTorch, TensorFlow, these are the frameworks which basically gives you a set of blueprint for writing a deep learning code where you will be making your artificial neural networks or doing any kind of a computer vision, image identification, image segmentation kind of task. Other popular tools which people or engineers actually use after like having a basic grasp of machine learning, making some kind of programs and projects, they have to do things like model evaluation, evaluating how accurate whatever they have model is. uh, like this is a new word called 1 minute, sorry. Okay, yeah, this is a new term called hyperparameter tuning. You can just search later about it. But just to mention, there are tools like MLflow, HyperOpt, Optuna to do that. Doing version control, again, good to have under a bucket: Git, GitHub, GitLab. Learning deployment and model serving using Docker, Kubernetes, and cloud platforms like AWS, GCP. So this is like a thing which you have to do much further, but like at least give like 6 months or a year to have a like good grasping on basics of ML, how to do a project, or like what kind of a problem you're actually solving, right? So like if it's a like first time thing for you, it will basically will take you like 6 months minimum to have a like really good understanding, keeping in mind that you are having other things also going on. um, so I think the last topic we have reached, how to start a career basically into ML. So like I just want to know like what you are looking forward after doing your bachelor's degree, and specifically the computer science students. Like, are you all just looking for for a software engineering job, or like do you have an idea of what you can do with other things? I think we can just rotate the mic and just get to know like a poll kind of thing between people.
Anyone? Anyone? I guess not.
I don't think so it's possible, like something that everyone must be having in their mind.
I guess they are just enjoying the college life as of now.
Okay. I mean, okay, that's also pretty awesome. You should. But anyway, just to give you spotlight on whatever you are learning, whatever you are interested in, and if you want to make a career out of it, which definitely every one of you will at a certain point. There are like two ways to like have like ML thing under your profession. One is to go through a research or academia way, or another is go through a corporate or like industry way. So in academia, you really have to have like really a good domain knowledge. So like this is a thing called research scientist, like which you can aim for, which basically requires a very specific degree. Like you at least have to do specialized masters or a PhD, really good programming knowledge, really good domain knowledge, a lot of research and experimentation, which basically makes you a research scientist. Or professor, which is basically a thing which you do after your like, you can be a research scientist, you can do your postdocs and like teach everything that you have learned in your particular domain and do a professor thing. So okay, telling about academia, what I mean about domain knowledge is like everything is too broad right now in ML and AI, and there are a lot of subsets. For example, my personal interest is in neuroscience and is in cognitive sciences, and that itself have a lot of subdomains. So I'm trying to find, okay, how a natural language processing and like brain psychology is working, like how a child is learning language, and if we are feeding the brain of the signal and the speech of a child to a model, and how it will be performing. So it's an example of how narrow a domain can be, and there are multiple thousands and hundred and thousands of specialized domains in this whole AI and ML space. So even people who have done their bachelor in different branches like psychology or even a bachelor's in mathematics, they can choose a master's in AI or ML. So but they basically will be having a knowledge of a lot of basic courses like mathematics and programming, but they can basically find an intersection to AI in these particular subdomains and become a specialized at it. So that's the process of academia. And a lot of people like I think from our university goes through this way. So yeah, like we can talk in detail whenever we will be doing this Q&A session. Second thing I want to talk about industry. uh, so there are like these detailed job roles, like there are a lot of other job roles like sister job roles, but the main that I could have laid out is like an ML engineer, data scientist, business analyst, product manager, AI solution architect, a pre-sales engineer, a AI consultant, a data engineer, a gen AI engineer, or a developer roles. So it's not just limited to a software engineering thing. You can basically do multiple things if you're a computer science student, and especially if you're learning ML. Um, okay, talking in detail, like what an ML engineer do. So whatever we have discussed about ML, you have to do all that. You have to do your software engineering part also, and maybe like whatever I'm speaking might be something more advanced to you, but I just wanted to give like a brief intro about like what all these job roles do expect. For example, AI consultant, you will be talking to a lot of your clients, providing them AI solutions, like how AI can help their business. Pre-sales, where you will be talking to sales team, you will be providing technical knowledge to your sales team. So what I'm like trying to say, you do not have to code. Like if you are in MS space, you do not have to write all those programs, do all this research. There are a lot of job roles that you can basically opt for. uh, AI solution architect basically define the whole architecture of the product, like of whatever application a company is trying to build. A business analyst, basically it business analyst actually have a lot of data handling knowledge and providing like profitable solutions to businesses. Data scientists also do something similar, but after getting data, a data scientist job is to get a lot of insights out of it. A data engineer role is basically just to handle data, like getting raw data, data warehousing, ETL, like and like learning all kind of big data tools. Gen AI engineer, this is like very hot thing right now. So after like emergence of this whole chat GPT wave, which is basically NLP model, it's basically a transformer model. A lot of applications are using these GPTs under the hood, and a Gen AI engineer, its basic job role is to understand what all those GPTs and LLMs and all these tools can do for a particular kind of problem, or how can they prompt like all these GPTs for a particular task that their company might want to do. And I mean, it's a very diverse role up till now, and I think like super interesting, super hot. uh, you should like really check out this Gen AI engineer, and I think that that's gonna be like something widely be widely will be like used by a lot of people, like in not just in IT domain, in all kind of domains. So and DevRel role is like it's again a very interesting role, like developer advocate. It's most of the people related with like Web3 domain, but I just want to say not a lot of companies have these roles. But like DevRel, developer advocate, is basically someone who understands the product, someone who understands the community, anyone who is using their product, uh, spreads right information about it, or even handle or provide or give feedback to the technical teams. uh, every company define their own DevRel roles by their own specific need. But yeah, again, very interesting role. You get to travel a lot, and there are a lot of remote options available. So last thing is, which is building a portfolio. Like how do basically you should target, like what should be your strategy. So I think basic have at least one kind of end-to-end project, and it goes basically for all these kind of job roles like that I've just mentioned. So while you are learning or while you are practicing, have one end-to-end project under a resume. Have at least one of the domain specific impactful project or any kind of research. For example, AI for social good, or doing something for sustainability, solving a sustainability problem, or uh, any kind of like any kind of problem that basically leaves some kind of impact, either for government or either for like social tribes or anything. mm, Intersection projects basically gives a boost and a charm to your resume. For example, if you are interested in social science, or like or maybe music, or like something like related deep into music theory, and you want to do something with AI to solve that problem. For example, for one of my master's course, I'm doing a project for uh, for females who are not mothers. So by circumstance, like not by choice, and there is a lot of data present of all the reasons, of all the genetic problems, of all the societal problems. So it's basically a whole topic of social science, but I'm using like data visualization approaches and AI approaches to get a lot of insights into this, and to get a lot of prediction. So that was just an interesting idea that I found, and so just wanted to give example of, if you have any kind of an intersection project, uh, uh, that will really give a charm. Again, hackathons actually give you like a very broad platform to like expand or make a kind of an MVP with the problem that they give. Uh, for example, like a lot of hackathons are posted on a website called DevPost. So if you go on DevPost, you will find example. I think I can just share a screen. 1 minute. Yeah. Mhm. So, okay, this is on the website dev post, and this is a hackathon that I attended, Azure AI hackathon, and we made this application for it called Locust Location Apprehension Module. So, it basically what it does is it in real time it visualizes the locust is basically that swarm attack that happens on African regions, by visualizing, and also visualizes the wind patterns. But under the hood, it uses a ML model to do those prediction of where the locust attack might be happening. And it uses data like, like uh, last 10 year humidity in the environment, or the wind patterns, or even the temperature, because all those things contribute to the locust breeding. So yeah, this is also a project for AI for social good. But like, so this was a hackathon called Azure AI hackathon. So it was hosted by Microsoft. So it gives you a lot of space to develop an MVP, and and you actually develop the whole application and get a lot of feedback from the community. So, and we actually won this hackathon. So then there's a hack for sustainable future with, so there are a lot of hackathons basically with different themes, different kind of prizes. So you should like really check out and try going for hackathons, I think. Yeah, coming back, so another thing is research papers. So I think this is also one of the things that you should might try. There are a lot of professors in the university itself which can help you get started with it. So, and it also gives you a good understanding about academic writing, and how all this process works. So yeah, this is also one of the thing I think you should really take care of. And if you can like get at least one research paper done, not specifically to ML field, like any field, it's a really good addition to your whole undergrad experience. Yeah, internships. Yeah, internships, definitely a good internship will always boost your career, and will provide you experience, will give you ground to make a lot of mistakes and learn about whatever you like, whatever you just learned as your skill, you will be really implementing to some kind of a project that people will be using. So again, a good thing. And I think like if you're going into ML space, you should like really target on some good kind of internships that will like really help you. And even it's not a ML specific internship, even a software engineering internship will work like very nicely to to do a transition in ML role later on, so that's fine. And if you're not getting an internship, do open source contributions, because those are the projects like handled by big organizations, big large code base. So it's more or less equivalent to like working for a company, but like your work is open source, and you can do it at your own pace. But yeah, you will be really getting an idea of how to work with large code bases. So that's the thing about building portfolio. And yeah, I think we have reached to the end. So I will really like and welcome all of you to ask any questions that you have. I think this is on mute. Sorry, this you guys are on mute.
Yeah, based on a few of the last slides, I wanted to ask about your opinion on entry-level jobs in AI ML, because say if we get our BTech 4-year degree, it is pretty much obvious that for software development and web development, people do get jobs. But after doing BTech, it is not very prominent to get an entry-level job in AI ML. We require specific like, specializations. So what is your
Uh,
opinion?
can someone just repeat what she said, because I missed out like two to three sentences, I guess, because of the.
बोलो.
Okay, so what I was saying is, that what is your opinion on entry-level jobs in AI? Because
Okay, okay. Mm-hmm.
because after getting a 4-year BTech degree, if one wants to go into software development or web development, it is very likely that they'll get a job. But for AI in this field, AI/ML people,
Okay, yeah, I get your question. So I think currently the scenario has changed a lot. Specifically in India, still there are a lot of positions available for software development or web development because the threshold is like very low. Like because there is a lot of demand for these kind of software engineers and threshold is very low for people to get in. So yeah, the number of jobs are more and number of jobs for ml engineers are still not as equal to comparable to software engineers and web development, but uh, now it's increasing, like definitely at least when I graduated, I found lot of couple of opportunities in these kind of roles. uh, Not sure if it comes on campus right now, but you can like really find it like off campus. Like a lot of job roles are present for data scientists and ML engineers right now, so I don't think you do have to worry of going into a software development role, or because yeah, it's like everywhere. Every company is needing a kind of a ML engineer or a data scientist or even a business analyst. So, and honestly, this space requires very specific knowledge, so you will always be on the top of the other crowd. So more chances to get hired for a good position.
okay, one more question. In our club, AI and the team was planning to create an AI chatbot, basically a data scraping bot which can produce like certain that's like resources for students, say a syllabus or a curriculum, etc. So for this, we used simple natural language processing on basic level, like we try to tokenize the words, and then we like created JSON file which had a whole lot of data, and then it would provide links. But then the issue which we were facing was that the bot was not able to cater to the very simple conversational questions. So with this, we
Okay.
tried. Yeah, so for this we tried collaborating with Gemini because Gemini would be able to.
I would suggest you to use Gemini for now at least, because it's like very new, still a lot of hallucinations in the model. I myself have tried that. So, but there are a lot of like basic LLM models like Mistral and everything, which is like really good, giving good performance. So you can give a try on that. And honestly, like if you want a conversational AI chatbot and you already have your data present, like what kind of questions people will be asking, I think you should go for RAG based approach. RAG is called retrieval augmented generation. So in which basically you can so LLM will be trained on some particular kind of data, and you can also give your own data, and combining the knowledge of both you can ask some kind of particular queries and get answers. So like it's like really, I think that's the best thing you can use for making a chatbot currently. So RAG based systems, you can maybe just, I can put it in the chat box.
Okay, any like this specific approach would involve like what all features do.
Sorry, what?
Like in this approach, we augment RAG-based approach. Like
Yeah,
it
yeah, we augment the, yeah, augmentation in this. So in RAG, augmentation basically means you're providing your own data also. So LLM is trained on a lot of data, which is basically helping all those conversational questions, like how are you, what's up, yeah, wo. And uske baad, like there will be some specific information that you might want to provide to your students, right? So you can augment all that data with this LLM and use retrieval mechanism to ask questions and queries.
and can you suggest few open source resources which we can utilize in this project?
Yeah, so you can try for Weviate. So Weviate is a open source like database, and it have a lot of extensions of all these RAG based approaches, and specifically for chatbot. I think so. There is a person who works at the company, Philip. He basically even send this to me to test. So if you, I think if you go to Weviate website, you can easily find out like their extension for chatbot. So yeah, I'll again type the name in the chatbot.
Okay. Thank you.
Yeah, sure.
Hello, Jeevanshi. First of all, thank you for giving us such an amazing program. I have two questions for you. First of all, I'm pursuing my major in statistics. I'm second year student. So, what should be my
Sorry, your major
uh,
is what?
statistics? Statistics.
Statistics. Okay, got it. Yeah.
So, what my question is to you is that what should be my approach towards building a career in data science? What MS programs should I look for?
So, okay. I'm not sure about what courses you are studying under statistic, but it sure would be able to give you any kind of basic knowledge that's required for ML, and definitely learning about three other domains of mathematics, which is linear algebra and calculus. Some kind of metrics methods, like which basically lies under linear algebra. So it will be good to go for you to go with ML, but I think as you are a statistics major, right? Like having like targeting for data science roles, like I think will be like very beneficial for you, because a lot of data science roles do require people with good stats knowledge,
Yeah,
honestly.
that's what I asked. Like, what should be my approach towards building a career in data science?
Yeah, so I think like the sort of things that I've mentioned over here in building a portfolio, uh, I don't think I have anything apart from it to mention. Like, you should like really start with like getting done with like data science projects, ML projects. Find it on Kaggle. Take it under a resume. I think learn programming specifically. So, and I think if you like just want to target for like data scientists, hackathons, I think really help you, because a lot of hackathons hire like on the go. So a lot of industry partners collaborate during hackathons, and I mean, each of the thing that I've mentioned can help you like through it, because for the entry level ML and data science, sometimes used interchangeably. So a specific data science job requirement come when you go to a senior position. So if you're targeting for entry level, like, so I think all these points like will be really good enough for you. There is no specific thing you can like follow. I mean, there is no linear path to something that you wanna have. You have to do like all these things, learn through it, build a certain kind of a resume. I think in third year you should focus on yeah, getting a resume in line. And yeah, second thing is I think be very interactive during in Kaggle communities, or showcasing your work, like build a portfolio, basically have your own website, showcase your work somewhere, or even post on LinkedIn. I think it will like it really helps and gives you a boost. So
Okay, thank you so much. Also, one more question. Please explain that regarding your student journey. How did you manage your academics and self-learning process? Because at times we are supposed to maintain a certain level of CGPA, and if you have to also know your certifications, this and that. So, a second year student is very tough
uh,
student, I would say.
see, I my story is very different. I was into University Dramatics Club. I did theater for 3 years. I did stupid stuff in college. I participated in a lot of hackathons for sure. But I got a research internship during my third year for with MITACS. So that started with my research journey. And in my second years, I started doing a project with one of my department professor, which basically was signal processing and AI. But okay, honestly, I want to tell you, It's nothing to manage like both. Like you do not require to manage both. You really have to find your own calling. So I'll tell you funny thing. I got my admits like for example, I'm pursuing a master's right now, but I'm doing it for like industry based. Like I have to do an industry internship for my credits. But I got admit for thesis based masters last year. I did not choose it. I I like and I don't want to do this research. Like I spent 3 4 years like applying for these colleges, doing my research internships, writing 3 4 papers, not even choosing a job. So, but then I like my mind changed because I realized a lot of things later on. Like maybe the research that I'm expecting to do is not something for me. Maybe academia won't be able to give it to me. But and even the calling started after like knowing about yourself, like what you exactly like are you really interested in some kind of a problem, or you're just doing it for the sake of it, or maybe just to say like you are as good enough as other scientists or other research scientists. So that should not be a calling at all, I think. Well, my personal thing was like I want to do something on the cognitive sciences aspect because I was always interested into psychology, like always. And even now I have a lot of certifications under me. I take workshops for people. But I wanted to make it like connect with tech, right? My own profession. And there's a professor who basically do all these things. I have a project under her right now, but that's independently. I am not specifically doing a research degree for that, and I'm just doing it because I'm interested into it. So that's why I said like a domain specific knowledge is required for academia, and like you really have to target for that, like what domain you are interested in. uh, so if you're interested into it, like then really should target for it. But honestly, excelling into academia is a little tougher than excelling into industry. So that I will say, specifically after talking to a lot of PhDs around me. Oh my God, it's a hell of a journey. Like you really have to dedicate your whole life, not whole life, but most of your time into gain as expertise as you can. And that goes same for any other kind of job role, but you can still balance it. But if you're in academia and if you want to climb the ladder up, you really have to go through uh, a lot of like deep work. So but for a undergrad perspective, I will say, I mean, I think just explore, like do research projects. Because honestly, specifically in computer sciences or a machine learning part, there is no clear distinction. Okay, a research is research, and like just project is a project. It can be interchangeable. So whatever you're researching on, you can make a project out of it, right? Show it on a resume, or even publish your work. So yeah, it's pretty like there's nothing called manageable. You can do both on the sides, because you're just implementing your ideas, right? तुमको रिसर्च करना होगा, you will have to test it, experiment it. So आप उस टेस्ट एंड एक्सपेरिमेंटेशन से प्रोजेक्ट बना लो. It's that simple. So I think, yeah.
Thank you so much.
Yeah, yeah, sure.
Anyone else? Any questions? Literally and basic also. How to expand or something like that.
Sorry.
Actually, I'm just asking one question whether they have more questions or not.
Okay, okay.
Guys, come on.
What was your branch in undergrad? Electrical. So how did
Oh,
you transition from electrical to
my
civil?
branch was very easy. I was into electrical. Very nice. First year I studied in first year. Second year I just studied one course. What कौन सा था? Sorry, I forgot it actually. Machines, some electrical machine course that I studied very honestly. But after that, it was too heavy for me. I'm like, I know the concept, understanding, but I did not really study it for marks. Like, I was good enough with managing a below 9 GPI. I mean, honestly, I won't advise it to you. It's always good to have your GPI like more than 9. because it will, if you want to target for good colleges, it really helps. Otherwise you have to compensate it with your like a lot of good research work or something. But see, one thing, even me studying in a like really nice university now, taking really good courses, I still don't think your university courses help you like a lot. Honestly, they don't. So they are just like a blueprint ki ha, like these are the things, whatever you're interested in, pick one, deeply study it, and everything else just study it like you were doing a class 10, like आपको सारे subjects पढ़ने पड़ते थे, and just to grab a basic understanding about what is it. So I think that's the same thing with undergrad. And main thing is a final year major project, do something that you really like. It's like always fun, एक अच्छा सा final year project करो, मजा आएगा. uh, but with courses, don't take too much stress and on assignments and courses. Like, I won't say कि पढ़ो ही मत, cheating करो, but I will say just have a basic understanding, and put your maximum time into like, yeah, learning skills apart from it. But also don't follow the herd mentality, which I think most of the colleges do, about like competitive programming or like DSA, or just to crack your fang or all this. I personally hate that thing. Yeah, you should have your own like DSA knowledge, but like choose, like explore as much as you can. And honestly, market out there, like right now it's really bad, like people are getting a lot of layoffs. So kitna bhi knowledge ho, how smart you are, if you're not able to make yourself like multi-skill, you won't be able to survive in markets out there. So no matter how like talented you are or skillful you are in one particular thing, but what if the outer circumstances are working not in your favor? What if you're jobless for 6 to 8 months? What will you do? Like, you really need to have something on the side also, like to learn as a skill. Like, make yourself more multi-skill. It always helps in life, and even your profession also. You will always be set apart wherever you will be working.
Thank you, Dee.
Yeah.
Any more questions? Okay, Didi, I guess we should wrap up. It's also about time. It's also late for you out in there.
Yeah.
It's midnight. Thanks for joining. On behalf of all of us, I would like to thank you for this insightful session for today. Hope to
Yeah,
see
it was
you.
good to see. Yeah, it
Yeah,
was good to see Assembly Hall also after so
yeah.
long.
I still remember when I was in my first year, there was a session for
Yeah.
GDSC and you were the
Oh
speaker.
shit, yeah. My leg was broken.
Yeah, yeah.
And I came for that.
Yeah, I
See.
still, people didn't. I still remember that. And since that moment,
Yeah.
I had this idea in mind. If I ever would never become a GDSC lead, I would surely invite you once again for a session. And here we are.
Oh yeah. Means a lot. Thank you. Yeah.
Likewise. Thank you, Didi, joining for us today for us
Yeah,
this session.
okay.
Bye.
Yeah, take care. Yeah. Have a good day, everyone.
Bye.
Bye bye.